Very good morning to one and all. Today I am explain to example number 4, which is based on the block diagram reduction rule. In this example, to obtain the transfer function by using block diagram reduction rule. So here R of S is input. There are the gain of G1, G2, G3, G4, and H1, H2 and H3 are the feedback. Okay, so first we observe the block diagram. So where will we start? So first we observe there are the various feedback path. So we separating the summing point in the feedback path, and first we observe that the block G1 and G2 are in parallel. So first we reduce these blocks. Okay, so let us start. So solution. Combining G2 block gain G2 and G3 and separating the path linked by summing point. In the feedback path. In the feedback path. So first, if you observe G2 and G3 are in parallel. So when these blocks are in parallel, the then blocks will be added. Okay, so we can add these two blocks. So we can write down. We write down again this block diagram. R of S, that is input, summing point, G1. Here G2 and G3 are in parallel, so these two blocks are in parallel, they can add here. So G2 plus G3. After adding these blocks, the path linking, separating path linking by the summing point in a feedback path. So we can separate. So we can combine first feedback path H1 and H2. So that is to be obtained like this from here. So this path H1, H2 here. So we can draw first feedback path. That is H1, H2, C of S, and the second path, that is this. Here we'll see G4, H2, and here to remove this negative sign we add a summing point which is removed. Consider by introducing a -1 negative block. Okay, so to remove this negative block, see here I want to remove this negative sign, so we add a -1 block here. So automatically this block, this negative sign will be removed. So we consider the second feedback path like this, G4, H2 and this, and we add one extra block here to remove this negative sign. So we can get structure will be like this. G3, minus 1 block is added here to remove this negative sign, and this feedback H2. Okay, we can again draw in simplified format. So we can restructure this simplified format. So we can get R of S one these blocks are in series. So when this block is in series, they are multiply each other. So we can shift this path to upper side restructuring. So G4 into H2, summing point, that is plus, and here is a minus. The blocks G1 and G2 and G3 are in series. These are in series. So when blocks are in series, they are multiplied each other, and these blocks are also in series. So we can combine into one. So we get G1 bracket G2 into G3 bracket complete, feedback path negative sign, that is H1 and H2, H1 and H2, and here C of S. So we can simplify here. Now if you observe the block 1 here, these are in parallel. So we can use the parallel rule number 3, and we can use the minor feedback here we can observe. So we can use the minor feedback rule. So we can obtain the transfer function so R of S is equal to, when these two blocks are in parallel, they can be add each other. So 1 plus G2 G4 into H, then by using feedback rule we can reduce this. So we get G1 G2 into G3 divided by 1 plus H1 H2 G1 G2 into G3, and here C of S. Now if you observe these two blocks in series, so we can get a transfer function. So when these two blocks are in series, they can multiply each other, so we can get R of S is equal to into one combined block after solving. So 1 bracket 1 plus G4 into H2 bracket G1 G2 into G3 divided by 1 plus H1 H2 G1 G2 G3. This is C of S. Then C of S is equal to divided by R of S, that is a transfer function, is nothing but 1 G4 into H2 bracket G1 G2 G3 divided by 1 plus H1 H2 G1 bracket G2 and G3. So this is the required transfer function for the given block diagram. I hope you understand this example. If any problem, you can write down in comment box or in personally WhatsApp. So we can stop here. Thank you.